Hello everyone, welcome to our lesson on inverses of relations and functions. Now I did not write down all the directions for these first example on the active board. You have them on your sheet of examples that have been attached to Google Classroom. But let me just remind myself what the directions are going to be for this. The directions for this problem are going to say, please find the inverse of this relation. So finding inverse of a relation is one of the easiest problems you're going to do in Algebra 2 this year. If you want to find the inverse of a relation, all you do within each ordered pair is you just flip around the x and the y. You do not change the sign, however. You just flip the numbers around. So what is the answer to this problem? Maybe I'll continue to do the answer in red so you know that this is the answer. The answer is going to be the ordered pair of 4, -8. The ordered pair of 0, 3. The ordered pair of -4, 5. And guess what? We have just found the inverse of this beginning relation. That is so easy. Just remember, don't change the signs as you flip them around. That's a common mistake some students do. They want to be overachievers. Okay, moving on to the harder problems. Now, we actually studied how to find an inverse of a function towards the end of Algebra 1. Actually, not towards the end, probably in January of Algebra 1, but it's been a long time since then. There's about 4 basic steps to finding an inverse of a function. Step number 1, get rid of f of x. Remember, f of x really is the same thing as a y. So that's the first step. We're going to get rid of f of x. Second step, switch your x and y around. So y is going to become x, and this x is going to become y. Third step, resolve for y. Get y by itself. So I'm going to subtract 1. I'm going to get x minus 1 equals -2y. I'm going to divide by -2. Now hopefully nobody's going to have a problem if I flip this around as I write. I kind of like it to be the opposite way. And the fourth step for finding inverse of a function is to show people that's what this is. So what is the notation for the inverse of a function? It's where you have the inverse of f of x. You just have f of x with a little negative sign by the f. This tells you this is the inverse of f of x. And I write down the answer that I found, and I call it good. Done. One thing I might point out is that sometimes the back of the book might go a little farther. The back of the book maybe would take this answer and write as 1/2 x plus 1/2, where they broke it apart. You do not need to do that for my sake. However, if we were to look at this problem and graph it, which is one of the things that you're going to be asked to do, and I'm just going to try to do it from a homemade graph from here. Hopefully this will work out. So what you would do if you were graphing this, you would graph your original problem, which means that at the y-intercept of 1, we should go down 2 and over 1. And we could continue doing that, but this is what you're going to graph. This is your original line. Then we would come and we would graph our inverse. So I guess, you know what, I kind of did need to split that up. Otherwise this would have been, I would have had to make a t-chart and put in points. Splitting it up, I'm going to see that my y-intercept is at 1/2, and I'm going to go down 1 and to the right 2, and I'm going to graph this. Now, why are they inverses? Because inverses have a line, a situation that if we could fold our graph along where y equals x, this is a line of symmetry for inverse functions. This half would fold exactly onto this half. They would match up exactly. So this is finding the inverse of a function and then graphing the original and graphing the inverse. Okay, moving on. Here's another problem. So we're going to reiterate the steps. Step number 1, get rid of f of x. Change it to y. Step number 2, switch your x and y around. Step number 3, resolve for y. So, how do I get rid of a 5 on the bottom? Multiply by 5. This goes away. Now we have 5x is equal to y plus 1. Subtract your 1 from both sides. Now we have 5x minus 1 equals y. And we want to write it so that it's in function notation. So instead of y, I'm going to use the inverse of f of x. And I'm going to write down 5x minus 1. Okay, as we come and we graph this. And by the way, remember you have packets of graph paper in your homework packet that was originally sent home. Please kind of use it sparingly. I'm not sure what's coming up after this, but I try to put a few extra sheets in there in case we have to do some graphing in the future. So again, this time I think what I'm going to do is I'm going to graph this guy first because he's easier to deal with. So I'm going to go to where the y-intercept's -1. Tells me I need to go up 5, 1, 2, 3, 4, 5, and over 1. Okay, normally I would do this one more time, but I'm on a homemade graph with this horrible pen, so I'm doing the best I can. Coming up here, I might want to convert this over. This is going to become, because there's a 1 here, this is 1/5 x plus 1/5. Now this would be very hard to graph. We're going to do our best job. The problems I picked for you to graph are a little bit easier than this. So my y-intercept's at 1/5. I'm going to go up 1 and over 5. So I'm going to be kind of like right here. And then I'm going to graph this, and we'll see how we do here. So, whoops. Pen is not the best, guys. So you're back of a galloping horse, you're going to pretend I did that really well, right? Okay, so again, if you could imagine this line going through here, with this half fold onto this half. It probably doesn't look like it on here because remember I'm doing a very rough graph. It would be if I was using a ruler, like you're going to from your packet, homework packet, to draw your lines. Okay, so this was one part of my answer. The graph was the second part of my answer. Moving on. Ooh, I forgot to write that example down. Let me do it. Okay, fourth example. Let me go in the blue, I don't like orange. Okay, so this is my problem. We want to find the inverse. You have a problem that has a square determinant in your homework. I'm not asking you to graph number 24. It'd be very difficult to do. I find every year I have to help kids in class the next day with the graph of it. Not going to do that virtually. So again, step number 1, get rid of f of x. Step number 2, switch your x and your y around. Step number 3, start solving. And if you don't mind, I'm going to flip this problem around so we look at it this way. Okay, still not done solving for y, so we're going to take the square root of both sides. We get y is equal to plus or minus the square root of x over the square root of 5. Well, we know that square roots in the denominator are naughty things, so we have to fix this up by taking top or bottom times square root of 5. Now, as I finish my problem, I get plus or minus on the top 5 times x, so I get square root of 5x. On the bottom, square root of 5 times square root of 5, I get a 5. So, not quite done because the fourth step says you need to show me that you found the inverse with your notation. So we go the inverse of f of x plus or minus square root of 5x over 5. Here we go. We're not graphing this one. Kind of hard. That's it, guys. Have a good day and good luck with your homework.